perhaps being influenced by the weather. So, so then, so there's some gas in the atmosphere that is actually trapping the heat of the Earth and re-radiating it out at height at a colder temperature. So this, whatever this gas is, it's actually acting as a blanket, trapping some of the heat in. So I asked people what this gas is, and the answer is...
Carbon dioxide?
No, it's not carbon dioxide. I'm glad you said that.
Water.
It's water vapour, actually. It's water vapour. Now, just to make absolutely sure, I mean, this is a sunny day here, but yet there is water vapour in the atmosphere. Water vapour is the gaseous form of water. So it's completely transparent to visible and indeed ultraviolet light, but it's opaque to infrared. And water vapour is actually the primary, what's now called greenhouse gas. It's the number one gas for regulating, maintaining the temperature of the Earth. This was actually realised by an Irish physicist called John Tyndall, who back in the, so you can see from the photograph, Victorian chap.
Had a magnificently Victorian turn of phrase too.
Brilliant turn of phrase. I mean, I just read it out because it's sort of, I wish I could write like this. This aqueous vapour, water vapour, is a blanket more necessary to the vegetable life of England than clothing is to man. Remove for a single summer night the aqueous vapour from the air that overspreads this country, and you would assuredly destroy every plant capable of being destroyed by a freezing temperature. The warmth of our fields and gardens would pour itself unrequited into space, and the sun would rise upon an island held fast in the iron grip of frost.
Great. We would be able to write like that if we didn't have to learn category theory.
Yes. So, just want to say a bit more about water in the atmosphere, because water is a key quantity in the atmosphere. So here's another one of these animations from space, from a geostationary satellite. We're looking down over the sort of tropical western Pacific. This is China, goes to China. Here are two lovely, by the way, hurricanes or tropical typhoons, as they're called in that part of the world. I'm going to show this again, because what I actually want to show you. So this is an area where there's thunderstorm clouds. Look at this, thunderstorm clouds being created. And what's happening is they're sucking up air into the atmosphere, into the high atmosphere, and throwing out water in the high atmosphere. So these thunderstorm clouds, particularly in the tropics, are a source of water in the high atmosphere. They're a source of this kind of greenhouse gas that's keeping us warm. That's a key point to look at later on. Okay, but there is a second greenhouse gas. Molecule for molecule, it's actually not as important, but it has this trend. So this is carbon dioxide, and this is a measuring station in Hawaii that's been measuring carbon dioxide concentration since about 1958. And we're going up pretty much to the present day. And what you see is, unlike water vapour, it's got this inexorable upward trend over the years. It fluctuates like this because of the annual cycle. So in summer, the vegetation of the northern hemisphere is obviously more active, and that takes in carbon. And in winter, so in summer, there's an intake of carbon from the atmosphere into the biosphere, as it's called. And in winter, the biosphere is less active, so there's this annual cycle of carbon dioxide. But superimposed on that is this trend. This is in parts per million, so we're down here at about 315, up here 380. Now, it is, I think, one of the uncontroversial, even the most diehard climate skeptic has to admit that this increase in carbon dioxide has been caused by man, caused by mankind burning fossil fuels, either through coal-fired power stations or jet aircraft or motor cars and such like.
Is that an exponential?
Well, it is what it is. I mean, you can probably fit some problem through it quite well.
No, I just wondered if that would give us a clue for the disaster.
Yeah, well, it's up to us to some extent how that curve goes in the future. This, by the way, I was going out to London the other day, and there's a free newspaper. So normally they talk about interest rates hitting 20-year highs, but here CO2 levels hit 30 million year high. So this is on the basis that the value for 2005 had just been released by the people in Hawaii, and it was 381 parts per million. Now, I think this 30 million years is a bit of an exaggeration, but you can go back and look at ice cores and find little bubbles of air embedded in the, in the ice cores of Greenland and Antarctica and such like. So you can measure CO2 in air that's, a million years old at least anyway, and certainly 381 parts per million is more than has ever been measured in these ancient air pockets. So we're talking about levels which are certainly unprecedented in the sort of last million years anyway.
And sorry, it's not of interest, from the ice core evidence, can one show a continuously rising trend, or are there troughs and is there a periodicity?
There's very little actually. It's fairly continuous actually. Okay. Through the ice ages, it tends to go down. It is true. I mean, during the glacial interglacials, there are fluctuations, well, I mean, what I should say is, so during glacial interglacials there are fluctuations, but since, the recent, let me start my answer again. What I said was wrong. It's been increasing since the Industrial Revolution, basically. Now, since then, it has gone up and down, basically with ice ages. So if you go over 1 million years, then you can look at several past ice ages.
You mean before?
Yes.
You said since then. We have had a
since the last ice age, it's been fairly constant, except since about 1800 or so.
When it's been rising clearly because of.
So most of the variability is associated with ice age fluctuations. Now, this statement is really the crux of why there are uncertainties about global warming. If you remember, I said, there are a number of uncertainties, but if I had to isolate one, it's this. I said to you that basically it's water vapour that is the key greenhouse gas. CO2 is a kind of secondary one. CO2 is increasing because of man. The question really is, how will increases in CO2 change the water loading of the atmosphere? So naively, one would sort of say, and indeed many of the sort of simple models have this in them, that as you warm up the atmosphere, say if you start to warm the atmosphere by increasing CO2, then this evaporation from places like the tropical Western Pacific will increase. So there'll be more, a warmer atmosphere can hold more water, basically. So as it holds more water, then that increases further the water content. But the problem is, as I showed you, that water is in reality, it's a kind of complicated gas. It's not well mixed, and that's one of the reasons why we use models. Before I come to talk about models, this is some historical evidence that we are seeing a problem. So the instrumental measurements of temperature around the globe really only go back to the late 19th century. I mean, places like Oxford have temperature records back to, 1600 or something, but the trouble is that's just one location. If you want to get some measure of global temperature, then obviously the global records are, can exist back 100 or so years. If we look at temperature over about the last 100 years, over land we see this, over the oceans we see that, and in combination we see that. So we are seeing an increase in temperature of, whatever that. So over land, maybe 1.5. This is Celsius. So this is an American thing. This is Fahrenheit. This is Celsius. So it's about one and a bit degrees over land, and a bit less over the ocean. By the way, you'd expect land's got the surface of the land has got a smaller heat capacity. The ocean can sort of transport heat down at depth, so you don't get less of a surface change over the ocean than land. Now, this itself doesn't prove anything, because of course some people say this could just be natural variability, and I agree. This itself isn't a proof of man's impact on climate.